Let's take a look at example 5.6 from your textbook, the example of the jumping bug. We have a bug, I think it says grasshopper in your book. I can't draw a grasshopper, all I can draw is this. And the bug jumps at a 45-degree angle, reaches a maximum height of 1 meter, and then lands. So just from this information, can we figure out what the bug's initial speed was when it first jumped? We can if we use conservation of mechanical energy along with a little bit of our knowledge from kinematics. So we set it up in the same way as we set up the previous problem, where we write this conservation of mechanical energy equation as initial potential energy plus initial kinetic energy equals final potential plus final kinetic. And for this situation, initial refers to the jump, final refers to the maximum height. So final's not when the bug lands, final's when the bug's at the highest height. And we'll put in our formulas that we've learned. Gravitational potential energy is mgy. Kinetic energy is 1/2 mv squared. Now, we can measure the height starting at ground level. So let's say that y initial is 0. We can cross this term out. Now it looks like we have one equation with 2 unknowns. So if you look at all the stuff in this equation, we can cross all the m's out, so it doesn't matter that we don't know m. And we know y final, that's 1 meter. But we don't know v initial and we don't know v final. But if you think back to our kinematics, 2D kinematics lesson, remember that at the maximum height, there's no y velocity, it's all x velocity. So this v final is equal to the x component of the initial velocity. So v final equals v initial cosine 45 degrees, the x component of that initial velocity vector. And cosine 45 is 1/√2. Okay, so let's substitute that into our equation. We'll also divide all these m's out, because every term has an m. Those don't matter. So we've got 1/2 v initial squared equals gy final plus 1/2 1/√2 v initial quantity squared. Now we can do some algebra. The initial squared 2gy final plus 1/2 the initial squared, and we'll subtract this from both sides, giving us 1/2 the initial squared equals 2gy final, because this is 1 v initial squared, and we subtract 1/2 from it, so we get 1/2 v initial squared. And that gives us 4 4gy final square root, or if you prefer, 2√. g is 9.8, we know y final is 1. And when you plug in the numbers, you find that that bug launched itself with an initial speed of 6.26 meters per second. So here's a problem that we can analyze using conservation of energy, along with a little bit of extra knowledge that we have acquired along the way.